Ever wondered how Netflix predicts what you'll watch next? Or how businesses forecast sales? The secret is linear regression, a simple yet powerful statistical method used in AI and data science. Today, we'll break it down with real-world examples, step-by-step explanations, and practical applications. Linear regression is a fundamental statistical technique used to understand the relationship between two variables. Imagine you're running a business and want to determine how your advertising budget impacts sales. By plotting this data on a graph, we can draw a straight line that best represents the trend. This is the essence of a linear regression model. Mathematically, it is represented by the equation y equals mx plus b, where y is the dependent variable, the value we want to predict, like sales. X is the independent variable, the factor we control, like ad spending. M is the slope, indicating how much y changes when x increases. B is the intercept, the value of y when x is 0. In simple terms, linear regression helps us make predictions based on past data by finding the best-fitting straight line that explains the relationship between two factors. Linear regression is all about understanding relationships between two variables, an input and an output. Let's say a business tracks advertising spending and revenue. If we analyze this data, we might see a pattern. More ad spending usually leads to higher sales. Here, ad spending X is the independent variable, the input we control, and sales, Y, is the dependent variable, the output we want to predict. Linear regression helps us find a relationship between them using a straight line. There are two main types of linear regression. Simple linear regression. Only one input variable X predicts the output Y. Example, ad spending versus sales. Multiple linear regression uses multiple input variables x1, x2, x3, xn to predict Y. Example, house price prediction. x1 equals size of house. x2 equals location rating. x3 equals number of rooms. Remember, more variables equals better predictions. To create a linear regression model, follow these steps. Collect data. More accurate data equals better predictions. Plot the data. Helps us visualize the trend. Find the best fit line, using the least squares method. Make predictions, using the equation y equals mx plus b. Our goal is to reduce the gap between actual values and predicted values. This gap is called error, and we minimize it using the least squares method. The best fit line is the one that keeps the total error as small as possible. Linear regression is everywhere. It helps businesses predict demand, guides AI models in self-driving cars, and even powers recommendation systems like Netflix and YouTube.